Okay, there we go. Okay. Welcome back to the Caribou Data Science channel. This is Thursday evening, January the 19th, 2023. And we'll be back here, folks, in about 15 minutes to get the show on the road. The first agenda, we're going to respond to an email, or actually, it was a post to the Puppy Linux forum. The response really wasn't a very good one from one of the admins, but I'll get to that in a minute. Then we go continue to look at something else. I'm not quite sure. We may not. We may go back and do the final assignment for the second module of the data science lab on QuantMod on WorldQuant University site. Or we may do something else completely different, depending on who shows up and if anybody shows up at all. Okay. This will, of course, be the last stream of the week. I'll pick it up again for sure on Monday night. But you know what? If you click on that subscribe button and click on that bell icon, you'll be notified if I decide to do a stream on Sunday night. Okay, so that's the big plus for that. Okay, all righty now. Anyway, so welcome back, folks, and we'll see you here back in about 15 minutes. Okay. Because because that kind of yeah. First of all, that can come in pieces. That can come in. If you look at the format, there's a good 20 different. If you search for YouTube, you get at least 20 artists compiled. One of them read all the afterthought. The other thing is that kind of defeats the purpose of using puppy. The purpose of puppy is to keep it light. Lots of extra power. Because a lot of these ceramic compilers are not for these things to create really a full version universe with no habits of install. But see, that defeats the purpose of using puppy, right? I mean, well, minimize what he said. Full blown. Um, of Apollo 20th mission. What was the last one? Okay. So what happened to 18 and 19? Okay, welcome back to the Caribou Data Science channel. And once again, it is the evening of January 19th. Is this a Thursday? This is a Thursday evening. Okay. Let's come over to Gmail. First a little bit of background here. As you know, I probably had Udemy Linux installed for maybe a year on here, or at least 6 months. It was a fairly recent version, 20.04. Um, had all the bells and whistles that come with Udemy. I installed VS Code, Python packages, R programming, R Studio and stuff, all in that. Then I decided just to get rid of it because it's taking up over a gigabyte of space or more. But I found myself I can't really seem to completely get away from Linux, so I went out and I installed a couple versions of now Linux. Puppy Linux claim to fame is that it's small, it's light, it's really designed to run in memory, or it's also designed for older hardware. So I began by installing. It is a very small distribution. I mean, uh, the actual ISOs probably isn't more than 100 megabytes at that. Let's just see if we can take a look here. You can see, okay, you can see the I have two installed. I have the Bionic Pup. This is it's Udemy Bionic basically. It's 362 megabytes uncompressed. Slack Pup is 410 megabytes. You can see they're fairly small distributions, but because they're small and light, you don't have a lot of all the niceties installed. You don't have like you don't have like a C++ compiler. Uh, and the thing kind of annoyed me was they didn't have the latest version. They didn't have a fairly recent version of Python. They're running on 2.7. So I posted a couple questions to the to the uh, to the forum. Tried a couple things, never really got to work. The trouble with the Slack Linux, I learned Linux on Slackware 20 years ago or more. is I haven't found a way to install it into a VMware file. I haven't found a way to do a install into a virtual machine yet. Okay, and that actually comes with like 10.6 or something like that, I think. Oh no, 9.6. The software, if you install Python, it's 9.6 or something like that. The best you can do is with Bionic is what is it? Maybe that's not right. Maybe Slack is, well, it's not. I guess it's nine. I guess it's 9.6. But of course, the yeah, this is true. The guy says, well, why don't you just build the Slack or the Python from sources? Like, well, that kind of defeats the purpose. Okay, that kind of defeats the purpose of using Puppy. You might as well use Udemy or something like that, a full distribution, and get this stuff out of the box. If you go to start installing compilers and stuff like that, it kind of defeats the whole purpose of uh, of uh, of using uh, Puppy. But anyway, so the last reply I got was from was this guy here. So I'm going to try to answer a response to the one admin posted here. One, because why do you, well, because it I mean, yeah, yeah, but first of all, guess what? Well, I have to install a G++ compiler. I mean, to me, if I'm going to start compiling program, that kind of defeats the purpose of Puppy. Because what I'm doing, I'm adding garbage onto it, garbage into. Okay, and that's my complaint. Uh, well, the reason I use version 3.2 is because that's what I run on Windows. The official Bionic has 3.6, as you already observed. No, the Puppy version of Bionic has 3.6. I didn't say Bionic did. I would expect the package manager to offer you this. Most things require, well, first of all, now, I actually don't want 3.11 because I tried to install 3.11 on Windows and I had problems with the packages. Okay. Uh, not to a certain, yeah, but see, if I'm going to do that, I might as well just install Udemy. I might as well install the latest version of Udemy. Okay, that's the point. Well, I don't know. Last time I tried 3.11.1, I had problems with it. Yeah, see, there's no GCC called. So the question still remains: why? The real question is why? To me, I don't understand why. Well, see, so I have 3.6 installed. So we're looking for pip, and there's nothing here. Well, yes, there is Python pip there. It's already been installed, so it doesn't work for uh, 3.6. So, so okay. Let's see. Why? It don't have, it doesn't have, no. It doesn't have PIP3. Hello, how you doing, friend? What should I call you? Shinto? Skinto? What should I call you, friend? What I'm looking at, I'm responding to a post I did on, you know, I've been a Linux guy since the 20th century. Yeah, so and I originally had a full blown installation of Ubuntu 20.04. I said, that's taking up way too much space. I want to try something a little smaller. So I got rid of that. And then I went out and I'm looking at Puppy Linux now. And, it's interesting. It's intended to be a small distribution, possibly run on older software, older hardware. And when I installed it, like Skinto, Skinto, okay, Skinto, yeah, good, yeah. And so I said, well, how do I install 310? And it's like, well, you just go out and compile into the source. Well, for me, that kind of defeats the purpose of using of using of using a distribution like Puppy Linux. The whole point is you don't want to build a bunch of crap on Puppy Linux. It'll slow it down. Okay. Plus, it doesn't have the GCC compiler installed. Again, I can install it from the package manager, but again, that defeats the purpose. If you have to start compiling stuff for on a light distro, then it kind of defeats the purpose of using a light distro. Because my problem isn't hardware. I got a decent laptop, but the point was to use a small distribution just to get just to do some of this stuff. Okay. Um, some respondents, the guy says, well, I'm curious, why do you want to use version 310? Because that's what I use on Windows. Okay, all my Python on Windows is 310. Okay, there are 311, but I have problems with package issues with 311. Why don't I install from this? Well, like I said, I don't have GCC installed. I don't, let's be honest about this. Back in my younger days, yeah, I did all that crazy building stuff from source. I built the kernel from source. I built, things like Apache from source. PHP from source. I've already done that. I don't need to go back there and do it again. Okay. So And that's the point. The point is, the other thing is, I was able to install Python 3.6, which is a decent level from uh, from the package manager. But pip, which as you probably know is used to install libraries, well, they don't have a version of 3.6. It's like, why would you have Python 3.6 available but not pip 3? Okay. That's okay. You'll probably sleep a lot better not using Linux. I mean, there isn't a good reason to use it for data science, which is what we're really interested in here, right? I will say Mac is fairly popular among data scientists, but Linux really isn't. But although everything you want to, you can certainly use Linux without a bit of problem doing data science because you can install Python, you can install VS Code, you can install R programming language, you can install R Studio, and so forth. Okay, all those are available for Linux. But you know what? Right, right, and you can actually install modules directly from libraries directly from, or you can install extension packages for VS Code uh, under in code also. Yeah, but yeah, PyCharm's fairly popular also. Yes, it is. So that's kind of the point. It's like So it's sort of like, yeah, it's easy to build, but that's not the point. That's not the point. I'm just kind of tinkering with Puppy Linux. I realize I can't do it completely without Linux, so I decided to go back and put again the total the ISO size for these Puppy Linux distribution is like 300 to 500 megabytes. So you can take you can build a VMware, a VMware virtual machine and put Puppy Linux in a gigabyte of space, okay, or give it 5 gigabytes of space, and it's perfectly happy. But anyway, so why not compile open source? First, Puppy Linux doesn't come with GCC installed. All right. Second, it seems to build a program from the source defeats the purpose of using PL in the first place. I might as well do a full install of Ubuntu. That's just the way I feel. I mean, I had it all installed. Now, in all fairness, he makes a good point. The Ubuntu 20.04 only had 3.6 Python installed. I had to go and make a couple changes, you know, to how it looks for packages, and I was able to install, I think, probably 3.10. Yeah, there you go. Uh, but I don't know, if you're interested in tinkering Linux, I would actually give Puppy Linux a look, simply because it's a small. Some of the versions are designed to run in RAM and memory, not even do a hard, not even do a an installation. Uh, I mean, he says, oh, the pip associated with pip would be pip 3. Yeah, but you but so why again? Why do you have 3.6 on available, but not pip 3? It doesn't make any sense. And the other thing is this: why are you using the version of Python 2.7 which hasn't been supported since 20 when support ended for that in 2020? You're using a system that has been supported for almost 3 years now. I mean, I went, and you know what? When I first installed Ubuntu, Python was pointing to 2.7. It's like, why are you pointing to 2.7 for? You know what I'm saying? Why are you pointing to? I went back. I just deleted the link, and then I created a new. Symbolic link to Python 3x. Okay, and everything ran fine. So everything runs fine on your system. Are you even working towards that? I mean, are you really even working towards the latest stable version of Python? I will say I tried to go up to 3.11, but I had trouble with some packages and stuff like that, so I just rolled back to 3.10. So there we go. And he's perfectly right. Yeah, I could do that, but the point is why. Here's Puppy Linux home, which is Puppy Linux. Oh, I don't know. Um, anyway, now this is interesting. This is being hosted on GitHub.io. So they don't even have a regular their own domain name. That's interesting. Okay, good. And there's a link to Puppy Linux. You want to try to install it yourself. Hey, Zidane, Tan, how you doing, friend? Thanks for stopping by again. I've been doing good. I was just bitching and moaning about Puppy Linux and their support people. Yes, I have. It's an amazing resource. It's an amazing resource. It's really close to being my favorite source for like our programming and stuff like that right now. I used to say your two best friends were Google and YouTube. I now think that Chat GPT is very close to being your best friend. Okay, I went out and I did a search. I said, what kind of packages are available? What kind of what R packages are available for making maps, and it gave me a list of like 10 different packages that R has for doing maps. Okay, but here's the thing: if you just want to if you just want to tinker around with Linux a little bit, Puppy's probably a really good way to go because it is small. You can actually load it into memory. Some of the versions have an install option. Uh, I mean, it really is very good. I mean, of course, you have to ask the right questions uh, in order to get the answer you want for it. Because if you ask the wrong question, you go get a wrong answer, or your question may not be. I think sometimes you have to like rephrase your question a couple times and it makes you get the correct answer. Anyway, so let's just take a look at a couple little puppy installation. This here is the Ubuntu version of I don't know what's called Ubuntu Puppy or something like that. Uh, and this is a Slackware puppy here. Now I was able to install this into a VMware virtual machine. I haven't figured out how to do this one yet. Okay, so what that means is it is nothing saved. But you come over here. Let's say you want to learn a little bit of shell scripting. Well, you can do that in Puppy Linux. Okay. Now, like I was saying before, I'm an old Slackware guy. I cut my teeth on Linux using Slackware back in the late '90s and early 2000s. Because Slackware was one of the first uh, complete distributions released. Okay, Red Hat comes much later. Ubuntu is much later. Uh, Slackware was the first one. And the first version of Slackware I installed was actually on floppy disk. That tells you how far back I go. I mean, I can remember when the Linux kernel reached 1.0. Okay, so you can see here we got nothing. There's nothing really special about this. You come over here like so and say, what? Yeah. So what I did here, I installed this version of Puppet Linux into a into an 8 GB partition, an 8 GB virtual machine. And you can see I still have about 8 GB left because it's very small. I mean, the installation ISO is like 300 megabytes or something like that. You can see here that the root is only used like 1.6 gigabytes. Okay, and it's got it's still pointing to 2.6. And it's not even a stable version of 2.7. It's a release candidate. Can't you at least put the latest version of 2.7 in there? Uh, okay, look what it says here. Python 2.7 has reached the end of its life in January 1st, 2020. Please upgrade your to okay. So that's fine. What else do we want to install? Now the question is, will my 3.10 code run on, or will 3.6 code run on? But see, I can't install. I can't install. So we can install this stuff. Let's install NumPy. Uh-oh. SciPy. That's interesting. Well, as you can see, now the question is, can I load a package from 2.7 into uh, right? So even though the 3.6 is available under Package Manager, they don't have the pip version available. What am I missing here? Let's see. Let's do a scaled mode. Here we go. Good. Much better. Let's go browse. So let's just go to see if we can find out how to install pip3 in Puppy Linux. You know what? I don't think I was able to get this to work. Okay. What do I do here? Okay, let's close this. The puppy manager is called, interesting enough, it's called PPM puppy, something puppy. Let's do this. Let's see if we can find Chrome. I think there's a version of Chrome here. So I select this done, and then I say do it. But you see, I'm installing another package now. course, one interesting thing about this is it's really intended to be like a senior user, a single user system, because there isn't really any. Well, it's a home directory. There really isn't any. Okay, so is this the compiler here, or is this the compiler? Or are they both compilers? Well, you know what? Let's just add both of these. Do I need to install base? What all? See, this is my complaint. What all do I need to install here? Okay, what all do I need to install? I mean, why would I know the answer to that question? Okay, that's the point. Menu, file system, internet, Chromium web browser. I'll try it. Okay, if it's already installed, how come you see how many chimneys do you see here? You know what's kind of interesting about this is I don't see uh, this on Windows. Let's come back over to Windows for a second, because this is Chromium and this is Chrome. Where's the sidebar? Where's the sidebar over there? So, yeah, this is odd. How come I don't see this on the Windows version here? I don't have apt-get. I don't have Pacman. Let's try one more time. Hang on a second here. Right. We got this here, and it's already installed, but it's the wrong one. Okay. What if Yum's on here? But you see, here's my complaint. Now I'm installing more software in order to install something by itself. Okay. To me, this to me again, this sort of goes against the spirit of Puppet Linux. I mean, the whole purpose is to keep it really light. To me, to a certain extent, installing packages like this, trouble with, isn't really a basic skill. Most people wouldn't know how to do it. Okay, let's go back over here to okay. So we want to do this now. Like I said, there really isn't a there. Okay, this is really a single user system, but there is no login. You got a root user. You got a user called Spot, which is sort of designed for like I don't has uh, restricted uh, properties. So we'll come over here then, right? We'll come over here to Yum, right? But again, why am I doing this for? Hmm, that's not very good. Is there actually sudo on installed? Sudo's installed. Okay, so let's come back over here. Let's just copy this code, right? So cut and paste doesn't work? Okay. First of all, so the question I asked earlier, are packages for maps, okay? And I got this list of all these different packages that are available for R, okay? Let's go ahead and close this. Oh, I didn't really want to do that, did I? Let's see. Let's go edit. How come? So now I got to go in and I have to add a, okay. Then I can use, now what does this mean? You can enable repos, but the yum config manager enable repo. Okay. That's a rather long command. Again, someone who's just starting out with Linux wouldn't know the answer, wouldn't understand this. Okay. All right. First of all, let's close this that this the same one. Now you see, how come I can't? See, so that's kind of annoying, and I don't know how to. Is there a different one here? Now, see, like I said, to me, this isn't an entry level Unix, Linux exercise. You know, going out, configuring the yum, and get a list of repos, and come back on the command. Well, the trouble was I can't cut and paste into a terminal. Let's see if there's a different terminal emulator. You see the trouble right there? Okay, so we want to do a yum. What do I do now? Hmm? What do I do now? I can't. I say that yum repo list, and there's nothing there. Okay. Well, Pac-Man. So the so again, see now we don't know how to get a list of how to get the list of available repos. Now we can go back to Chat GPT and find out probably what the point is. At this point, if you're just starting out, you're lost. You have no idea what to do. Now I got to go out online. I got to do some search. I have to post some questions to the forum and then wait for them to get back to me and this and that. And well, let's come back over here. Okay. So, okay, maybe I just read the command wrong. No, no, that's what it says. So now what do we do? Because we already tried, we put this up here all, right? And there was nothing there. Unless we have to have the backticks around it. Okay, can we come back over here then and install maybe Pac-Man's out there. Maybe we can. Well, what do you know? We can't do Pac-Man because it doesn't exist as a tool. Oh, we don't have apt-get, do we? The trouble is, of course, is this doesn't. We can copy this, but it won't actually work, will it? Now it seems like I may actually have that here. Okay, let's come back down here then. Let's do it. I thought I actually already had this installed. Oh, well, I have to have 3.7 or above. Let's well. What do you know? What do you know? But anyway, since we got Python 10.9 installed, we might as well. Oh, wait a second. No, cannot create executables. What do we do? Well, I guess what we do, we don't use Puppy Linux for Python development. And apparently we can't even use it for C development because, well, because of compilers. Now, Slack Puppy will install, I think 3.9 maybe. Okay, but I haven't figured out how to install it into a partition yet. So anyway, but you can do other things. You can certainly uh, you 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 can certainly you know just use this for to work on your general Unix administration skills and work on your shell, work on your on your work on other things because you still got all your favorite tools, right? All your favorite Unix all your favorite Unix text tools are there. Cut, set, awk, cut, unique, sort, and all that happy stuff is there. So you can work on your Unix shell scripting, okay? But if you want to work on your on your anyway, so when you shut it down, it's just a question of come on over here, okay, and exiting this. Okay. So anyway, let's come back over here. Let's go back over here. Let's just take a look at where we're at here. Okay. Again, this is WorldQuant University. WorldQuant University. Prepare for your future in data science. Uh, our rigorous degree master's program and continuing education lab. Okay. Entirely free. And when they say free, they mean free. They don't beg you for it. So far, they haven't begged me for money. Been no suggestion. You go on, you fill out an application, you pass a little quiz, and you're in like Flint. Okay, so if you're if you're new to data analytics and Python programming, I would highly recommend this course. The first lesson, it consists of I think 8 modules. Each module consists of say 4 lessons plus an assignment, which is sort of graded but not really. Uh, Very easy. The first lesson is all about introduction to Python, but it's all geared towards data science and analytics, not towards general Python programming. Okay, so if you're interested in data analytics with Python, this is the first one is this introduction to libraries, how to import CSV files, how to do basic data visualizations, a little data wrangling. Then the second one, things get a little more hairy. From the second module on, the second module is all about modeling, and in particular about linear regression models of different types. Okay, and it's also about in this last lesson, he introduced the idea of of, uh, of data imputation to replace missing values. Okay. Now I've finished the second module or the second lesson of the second module. Okay. Now they have an office hours, sort of like a live Zoom meeting. I haven't made it to one yet. Grades. Oh, here we go. Look at this. Now, in terms of passing the stuff, well, they give you all the code you need to pass. The quiz is like, you go to a section and they'll have like a coding question. You type in the code, you click Shift Enter, and it gives you the score. And it's nothing big. It's nothing big. They give you the answer to all the questions as part of the code. But as far as me, I'm actually been I've been writing down all the different code we use. Okay, and here's the one from the last session. Libraries, scikit-learn, scikit-learn, scikit-learn. This one here is a little grading package they have. Pandas, NumPy, Matplotlib. Glob was introduced last time, and so forth. Okay. Well, we need to keep that. We probably need to keep that one open. Okay. And it's all done on Jupyter notebooks. So this is the one we finished, right? So now we're up to 24. All right. Predicting price with size, location. So we have 3 lessons so far. The first one was prediction of the price made on size. The second was on location. The third was on neighborhood. Now we're going to combine all these suckers into a single one. So we'll come back over here. We are going to create a new file. All right. And the way this works, this actually has some simple markdown language to it. But when you put the open and closing backticks, this is what's called preformat. It simply means it's going to display the stuff exactly the way it's entered on the screen. Okay. There we go. All right. So as is all the one thing about there's a lot of repetition. You kind of do this. You kind of go back and repeat all the steps you did of each in the previous lesson. So you're constantly adding more. You're constantly going back, repeating certain principles, and then and then going on to the next lesson. Okay. So where are we going to begin? Well, we're going to begin up here. Okay. All right. And the way usually you hit Shift Enter, and that runs the first line of code. And what this is here, this is a little inline video, okay? So tell me, you guys, what have you been up to? I'll be back in a minute. I'm gonna get me something to drink. Okay, we got our initial data loaded. In the final lesson for this, so I guess we have is it 8 projects. I thought each project containing 5 lessons. That's the lesson. Ends with an assignment, or 4 lessons ends with an assignment, which is no big deal. In the final lesson for this project, we're going to try to use all the features in our data set to improve our model. This means that we'll have to do some more careful cleaning of the data set and consider some of the finer points of linear models. I'll be right back in one moment here. Some more chocolate? I want to note here. If if you happen to have anybody who's interested in data science, whether it's any aspect of data science or data analytics, by all means, give them the link. Send them a link to the channel, and let's because like I say, The more the merrier. So invite all your friends and family who are interested in data analytics to the channel, okay? I'll go back and say again, this is my last stream for this week. I will certainly stream Monday through Thursday and maybe Sunday, but if you're subscribed to the channel and you click the bell icon next to the subscribe button, you'll be notified whenever I go live again, whether it's Sunday or Monday night, but definitely Monday night, okay? Maybe Sunday, we'll see. Maybe we'll do the assignment Sunday night. We'll have to wait and see what happens with it, okay? Let's take a look at our first video here, okay? Let's just put this text over here. There we go. Let's see what this. I also say the instructor's pretty good. Also, most of the lessons consist of a series of five-minute videos.
Up until now, we've been trying to predict apartment price by looking at one or two features at a time. We started with size to see if we could predict price that way, and then we looked at location, both in terms of latitude and longitude, and then finally in terms of neighborhood. Well, this time I want to take all of those things and put them together. And what that means is that, first, our data is going to be a little bit messier, so there's going to be more cleaning we have to do. And second, we're going to have to go into some of the finer points of linear models. So those are all fun things that we have to look forward to in this lesson. I'm going to go over to the presentation here so we can talk about the specifics. And in terms of goals for this lesson, first, I want to make sure that, like we've been doing, we want to build a model to predict apartment price. Second, we want to evaluate all of the features in our data set for use in our model. So we're going to be looking at all of the features that come with those original CSV files. And then I want to create two different deployments of our trained model. And deployment, by the way, is when you take your finished model and you put it out into the world, either for other data scientists or programmers to use, or for users to interact with. So we'll be looking at two different kind of mini deployments of our model. So in terms of the ML workflow, here are the highlights. When it comes to preparing data, for importing, we're going to be working with our same wrangle function, but this time, instead of using a for loop, we're going to use a list comprehension. Then for exploring, since we're using the whole data set here, there are lots of issues that we need to consider. First, we need to look at null values, or when are there so many missing values in your feature that it's better to drop it rather than do imputation. Next, we have high and low cardinality categorical features. And these are categorical features that either have too few or too many unique values to be useful to your model. Then we have leakage, where you have features that are giving your model information about the target that it shouldn't have, kind of letting it cheat, which makes it difficult to interpret the model coefficients. For the second part, where we build the model, honestly, this part's pretty much going to stay the same. So if you felt comfortable in the last lesson, this will be a breeze. And if you weren't quite sure what we were doing in that last lesson, this is a really good opportunity to kind of reinforce and practice. And then last, we have communicating the results. And again, we have those two deployments. So the first deployment will be making a make prediction function. And then the second deployment we'll be creating an interactive dashboard, an MVP, a minimum viable product. So those will be the two deployments we'll be working
That's
with.
kind of interesting.
So let's get started and we'll jump into the lesson. Let me introduce you to some of the libraries we'll be using in this lesson. So we have old friends and new friends. For old friends, we have warnings and we have glob. Warnings will be for suppressing those warnings which we don't want to see. Glob will be for getting all of those file names of the CSVs we want to import. Pandas, you guys know very well. Pandas is for all of our data wrangling needs. Seaborn is a package that we'll be using for data visualization.
Nice.
After that, we have category encoders, which will be using the one-hot encoder for encoding our categorical.
I'll just mention that if you're familiar with basic plotting functions, meaning non-ggplot2 functions, in R, you'll feel right at home at Seaborn because the syntax is almost identical. Okay.
variables. So you guys know that one very well. After that, we also have, let's see here, we have IPy widgets, a bunch of things from IPy widgets. This is going to be for the interactive dashboard. After that, we have simple imputer.
Interesting. Okay. So let's see, Seaborn. Very nice.
For imputing missing values. And then for the linear models, we're importing two things. We're importing linear regression and ridge. And by the way, if you're ever curious as to why this little comment is here, that has to do with kind of the automated quality control we do for all of these notebooks before we give them to you. And if you're curious about learning more, you can search for PEP8, PEP8, and, just read in, see what you find. After that, we have mean absolute error for evaluating our model. We have make pipeline for making the pipeline so we can put all of the pieces together. And then we have check fitted, which is just going to be to do our own little unit testing of our work as we move through the notebook. So those are all the libraries we'll be using. And let's dive into preparing the data.
So we're going to load our wrangle here. Well, I got another reply back from the admin about Puppy Linux. I don't know. I may not bore you with seeing the replies to that Papa Linux post. I'm not really. At this point, I'm not really expecting a lot from the. I'll give the guy credit. He may be like an admin on the forum. He just taking time to explain. But to me, like I said, the purpose of Puppy Linux is not to go out and install compilers and build stuff from sources and stuff like that. Uh, it's to install a few packages and then get started. You know, it's supposed to be small and fast, no minimal space, minimal resource usage. Well, you saw it happen. I installed what I thought was the 3 files and needed to compile that source code. And yet when I did, it said, compiler cannot create executable. So I'm probably missing some libraries someplace. And briefly, what we did here is what? We came back up here, as it says, subset data, uh, from the place with the parent names, we extracted the capital Federale, which is the capital of Brazil. From property type, we extracted apartment, and from price approximate USD, we extracted only rows had less than $400,000 value. Then we calculated a quantile to get rid of the outlier. If we use the quantile function and we went from 0.1 to 0.9, assigned them to two variable names named low and high, and then we came down here. We said pull out everything between low and high, and then we pasted it back down here to. So this down here says only give us the this file here. Then we split out the long column into longitude and latitude, and finally we pulled out the place names using the string split function on the places with parent names. Okay, so there we go. So now let's begin by using, so task 2.4 is used to, what I don't understand is, well, how come we're, what's interesting is when I'm cutting and pasting this stuff, it's indenting everything. Okay. Let's take a look at this up here then.
Okay, time to start importing our data. Let's take a look at our wrangle function just so we can remember, kind of what it does. Now, this is the same wrangle function that we used last time, so this should be pretty familiar to you. It has 5 parts in it. The first part here we use to read the CSV file into a data frame. The second part, we use it to subset that data frame so that we're only looking at apartments in Buenos Aires that cost less than $400,000. The third part is another subset where we disregard or remove or clip all of the apartments that are either too small in terms of their surface area covered or way too big. So we remove outliers. The fourth part is we clean the latitude and longitude column by splitting it into 2 separate latitude and longitude columns. And then last but not least, we create this neighborhood column from the place with parent names column by doing a little splitting and a little substring magic. Not magic, it's just programming, right? It's not magic, it's data science. So that is our wrangle function. And if I clear these drawings and then zoom out, the first thing that we need to do is we need to use this, before we can use this wrangle function, we actually need to get the names of the files that we want to wrangle. So for that, we're going to use glob.
And of course, this was covered in the previous lesson, but anyways, it's always good. It's always a good, for me, repetition is truly the mother of all learning, particularly when it comes to short-term memory items.
And if I zoom in here, we imported glob up above. So the first thing I'll do is just invoke it here. And then I need to give the pattern for the file names that we're interested in.
What it was.
I know they're in the data directory, and I know they start with BUE. And if I use the tab complete, I can actually just get one of the proper names here. Now, I know that, and I'm highlighting it here, I know that
You guys are getting this all down, right?
the thing that changes is this number. So I'm going to replace it with a little wildcard operator, which is the asterisk. And so with that, if I run this cell, what I should get is a list. And indeed, this is a list, and it has 5 all 5 CSV files.
We come down here, right? All right. Then we run this. And there's our 5 files. And now here's our check a search. This is kind of interesting. This is an interesting thing. It's a search length files equals 5. Now, of course, we need to combine these and then run our wrangle function on them, right? Use our wrangle function. Oops, I forgot something up here, didn't I? I forgot my glob. There we go. Now let's watch this video here. It seems like we have to convert this to a, you can't simply use a PD concat. It seems like you have to convert it into something else first. Let's just see what this says here.
For this task, we need to iterate through the CSV file names that are in the files list, and then wrangle them one by one, and put all of those together in another list called frames. So this is similar to what we did last time in the last lesson. So let's just look at how we did it in the last lesson with a for loop, and then this time we'll then translate it or turn it into a list comprehension. So how did we do this last time? Well, the last time we started with frames and we had it as an empty list. And then we did we did for file in files. We did, df dot wrangle. We did df. Now, how did this work? We did df equals wrangle, and then we wrangled the file. And then after that, we did frames dot append df. So we went through every single file in files, and then for each one of those, we wrangled it, we turned it into a data frame, and then we appended that data frame to that list. So, whereas the list started as empty, as we went through it, 1, 2, 3, 4, 5, we added data frames to that list. So this is...
Okay, so in R, you would have to jump through all these hoops. You would import them all as data frames, and then you would use some type of row binder, and that's it. For some reason, people like to import in Python. Python guys like to import, as lists, and then do an append, and then convert them to a data frame. Supposedly in Python, importing directly into a data frame is slower. All right. So an empty list, right? File. The file comes from above, right? And this just iterates over all the stuff. df Now, see, at this point, it's still not a single data frame. It still hasn't, they still haven't been merged. That's the thing. Doesn't make any sense to me.
This is what the syntax looks like when you're doing a for loop. Now, let's change gears a little bit and turn this into a list comprehension. So what I'm going to do is I'm going to build the list comprehension in here, and what that will mean is taking things from our for loop and kind of dropping it into the list comprehension. So I'll be doing a little bit of copying and pasting. So the first thing that I want to kind of draw your attention to is this part, right? Where we tell our machine what we want to iterate through. So what I'll do is I'm going to take this for file and files. I'm not going to include the colon, and I'm going to paste it into the list comprehension, all right? So it's right here. And I'm building this list comprehension kind of from the back to the front. So this is kind of the end of the list comprehension. So you always start with that, what I'm going to iterate through at the end. And then what I want to do is whatever the actions are, which in this case is wrangling that file, I'm going to take that action and I'm going to paste it in here. All right. And I think that's it. I think I can erase all of this. And so what I'm saying is I want you to go through every file that's in the list files. And for each of those, I want you to wrangle it. So you go from the name of a file to a data frame.
Okay, I got one question. Where are you loving people at? Thanks to both of you guys for hanging out with me. I do appreciate it. Hope I haven't bored you too much of my ranting and raving about Puppy Linux. Uh, you know what's interesting? You can use ChatGPT to actually write Unix shell scripts. It can write scriptures and things like awk or set and stuff like that, and cut and sort and unique. Okay. Okay, so we're going to go from here. Okay, and what he did was I'm here. Okay,
And in the end, what we should have is a list that's full of data frames. So if I hit Option Enter, I get an error here, and it says, name error, wrangle is not defined. What do you think that error is about? What's the problem? What did I mess up here?
the question, did I mess it up? I think we're probably going to do something because at this point, I don't think it's a data frame. Okay. Let's see if I get an error. Invalid syntax. Oh, well, he obviously didn't actually run the function above. Okay. Didn't we run wrangle up here? Yeah, that's what it was. He just didn't run the he didn't initialize the assert the wrangle function above. Okay.
Well, if we zoom out, you'll notice that I scroll up here. Here's my wrangle function. And if we look right here, you can see that I never actually ran this cell like the dum-dum I am, right? So what I'm going to do is I'm going to run this cell. I'll hit Shift and Enter, so it's in memory. I'm going to scroll down to where I was before, and
Okay, I think it's at this point it's still not a data frame. Okay, that's the problem.
then I will zoom in again. And when I run,
You know what's interesting is now that I didn't realize before, but every time you run a command, it gets numbered. Okay, well, this is 13. All right.
this cell a second time, you'll see that it runs. So let's just inspect frames to make sure it's what we think it is. So if I look at the type of frames, it's a list, which is what I want.
No, it's
If
not.
I look at the length of frames, I get 5. So there are 5 items.
It's a list, and there's a list of 5.
Items in this list. And then if I look at type, not for the list frames, but for the first item, I can see that it's a data frame. And then last but not least, let's just do frame.head. And we can see here is the CSV file, which has been read into a data frame with kind of all of the different features that we need.
That's interesting.
And so
Interesting. Okay, good. Suppose I change this to 1. Hmm.
Just to review the way we did our list comprehension, we started with our list, so we had our square braces here. After that, we kind of started at the back, and we took basically the way we'd start a for loop, where we had the object that we wanted to iterate through. In this case, it was files. And then the name we wanted to assign to each item in that list as we iterated through that list, which is file. And we had that at the end of our.
I'm going to take one diversionary. I'm going to see if I can install Git and Puppy Linux. I don't think it's installed. Let's see if we can install pip using or hmm. I don't know why I installed girl for, but there it is. Okay. Oh, that's kind of strange, isn't it? What does that mean? No. So we don't actually appear to have get itself, do we? Interesting. All right.
Our list comprehension. And then at the beginning of the comprehension was the thing that we wanted to do to each file as we iterated through them, which in this case was just wrangle it. So we ended up with a list full of data frames, and now we're ready to put them together into one big data frame.
All right. So it's kind of annoying that I can't, daggone it, uh, that I can't, that I apparently can't install Git on there. So here we go. Concatenate two or more data frames using pandas. Okay. We should know how to do this, right? Because we've done it twice before. Let's just see what this says here. There is, of course, a PD concat thing. It's a simple. Let's see if this works. I mean, it's going to be close to this, right? There we go. Excellent.
Time to put the data frames together. So let's zoom in here. And what I want to do is I will do PD concat. So PD concat. And inside I'll put frames, and I want to make sure to set ignore index to true.
Oh, I forgot about that part, didn't I?
And so if I hit shift and enter, I should have, there we go. This looks beautiful. I have a data frame that has 6,500 entries in it. I can see that the index goes from 0 all the way to the last entry, so the index is clean. And then we have a whole bunch of other stuff here, which we'll be exploring in the next section, in the exploratory data analysis. One quick thing before we move on, let me scroll up here back to our code. And actually, let me take the code that we had up above and just paste it in so that we can see it in one place. So I'll just paste it in right here. Now, a lot of times when we're programming, we think like, oh, I want to make my code as compact.
Yeah, I guess, well, we could be heading toward a function here also. So let's just go ahead. But we can also move this. So obviously, my guess is we're probably moving towards another. I think we're probably moving towards a function here. I'm not mistaken.
As possible. I want it to be, sometimes people use the term Pythonic, right? Pythonic means I've done as much with as little code as possible. And one way that we could make this code more Pythonic is we could take this list comprehension and just paste it directly in here so that our code, we would lose one line of code, right? So in this way, it looks like our code is more compact. It's more Pythonic. However, one thing you need to consider when you're thinking about how to refactor your code is how readable is it? Is it easy to understand what's happening step by step?
Hmm. Personally, I couldn't care less about Pythonic as long as the code runs, right?
And that's why sometimes I think it's better to kind of do it this way, step by step, create the frames and then concat them. Because when you come back to this code 2, 3, 6 months from now, it'll be much easier to follow. And again, these are just kind of things that you need to balance as you learn to program. But just something that I wanted to point out to you guys before we move on.
But it still works, right? Now we come down to explore. So here we go. The first thing we need to consider when trying to use all the features of DF is missing values. While it's true you can impute missing values, there still needs to be enough data in the column to do a good imputation. And there we go. A general rule is that if more than half of the data in the column is missing, it's better to drop than try to impute. Take a look at the output from the DF info above. Are the columns there more than half? Well, let's see something. There's 6,000, so that'd be what? I don't know. Yes, expenses and floor. Oh, that's not good. Floor space, good grief. I don't know. So yeah, so more than half of floor and half of expenses is missing. I don't know, but I would think floor space is fairly significant. But anyway, right? Or do we leave off that? Hmm. That's a good question. Should we stuff as much stuff as we possibly can into a wrangle function at the beginning of the script? That's it. I would be tempted to actually keep this function separate. This so you'll see it.
We've imported our data, and now it's time to start our exploratory data analysis. Now, there are three areas that I want to focus on as we do our exploration. The first is the question of null values. And when you're looking at a feature, how many null values is too many? Like, when should you drop your feature and when should you impute? We'll talk about that. The second thing I want to talk about is high and low cardinality categorical variables. And then lastly, I want to talk about multi-collinearity. All right, so those are the three areas we're going to focus on. For now, let's just look at null values. So I'm going back to the notebook, and this is the previous task, and we were looking at info. And notice that we have some columns where there are no missing values. So we have 6,582 values, and we can see that in the operation columns, there are no null values. But contrast that with another feature, like, for example, floor. Let me zoom in here. It's a little bit easier to see. If we look at floor, we have a ton of missing values because we only have 2,000. We have over 6,000 observations and only 2,000 values for floor. Same thing with expenses. Now, if I zoom out for a second, this info readout is a pretty good way to get a handle on what your null values are. But let's just do a little bit exploring because you know what? We love We love what we do. Let's do a little bit more wrangling here. So what I'm going to do is, if I zoom in, I'm going to do df, and I'm going to use the is null argument, okay? And what the is null argument is going to do is, if we look at this, it's going to give me a Boolean data frame, and for those cells in the data frame where there are values, it'll say false. So this is a little counterintuitive, but what this means is basically in the first row in the operation column, we can see that there is no null value. So this is false. Now this isn't particularly helpful, so why don't we take this and instead let's do sum. And what this will do is it's going to sum along the x-axis, so along the column axis here. So if I hit Shift and Enter, what I get back is a series. And keep in mind that in terms of math, true, the Boolean true, always evaluates to 1. And so this is showing me how many trues or how many null values are in each. Only 4% of our observations are missing. But like we've said before, you have some of these big offenders like floor, where 70% of our values are null, or expenses, where 73% of our observations have a null value. So what does this all mean? Well, generally speaking, if your column has more than 50% missing values, then it's probably time to drop it. And what that means for us here is that the floor column and the expenses column, they gotta go. See you later. Sayonara. Goodbye. With that in mind, let's zoom out and go up to our wrangle function. And let's make some adjustments there because it is time to get rid of those null value columns, which aren't really giving our model the information that it needs to be useful. So what I'll do is, let's see here. I will just put in a little comment here. So I'll do drop features with high null.
So are you guys still there? I hope you're enjoying this, seeing me struggle with this Python programming again tonight. Against my better judgment, I'm going to take a look at the at that rascal's reply. Okay. Nah, I'll come back to that guy tomorrow sometime.
Counts. And let me zoom in so that it's easier to see. There we go. And this is going to be our regular old drop. So I'll do df drop, and then for columns,
That'll wait till later.
I'll set that equal to, let's see here. The two columns that we wanted to drop are floor and expenses. There we go. And I will set this to in place equals true. in place equals true. And I can see that autocomplete has kind of messed up my columns argument there, so I'll remove that. And then I'll hit Shift and Enter to rerun this. And if I zoom out, I can then... Actually, why don't I go down to the part of the task where I need to do this. So I'll scroll all the way down to my Explore. Here we go. And what I'll then do is I'll go up to Run and do, let's see here, Run all above selected cell. So this will run the whole notebook from the top down to...
You know what's interesting is this, right? Now here's the problem. It's possible that the person running the script may not see the function, or they won't realize, see, we looked and we know we need to drop because it's less than 50%, but shouldn't we be calculating the 50%? Rather than just simply filling in some numbers there? Yeah, I'm not sure we should be dropping a lot of columns in a function. I think that really is something that needs to be done separately. But anyway. Is that right? I bet he has a better method. I just know this rascal. He probably has something else up his sleeve.
Where I have my cell selected. There we go. And what we'll see is that this asserts...
Now, one note is this version of Jupyter Notebooks apparently doesn't have that run above function in terms of run options. You can simply run individual frames to run the whole thing.
Statement has run, and that means that my column is now, that those columns are now dropped. So we had 17 features when we first wrangled this data. Now we have 15. Let's keep on going. Let's see what we can keep and see what we need to throw away. We've imported our data, and now it's time to start our exploratory data analysis. Now, there are 3 areas that I want to focus on as we do our exploration. The first is the question of null values. And when you're looking at a feature, how many null values is too many? Like, when should you drop your feature and when should you impute? We'll talk about that. The second thing I want to talk about is high and low cardinality categorical variables. And then lastly, I want to talk about multi-collinearity. All right, so those are the 3 areas we're going to focus on. For now, let's just look at null values. So I'm going back to the notebook, and this is the previous task, and we were looking at info. And notice that we have some columns where there are no missing values. So we have 6,582 values, and we can see that in the operation columns, there are no null values. But contrast that with another feature, like, for example, floor. Let me zoom in here. It's a little bit easier to see. If we look at floor, we have a ton of missing values because we only have 2,000. We have over 6,000 observations and only 2,000 values for floor. Same thing with expenses. Now, if I zoom out for a second, this info readout is a pretty good way to get a handle on what your null values are. But let's just do a little bit exploring because you know what? We love what we do. Let's do a little bit more wrangling here. So what I'm going to do is, if I zoom in, I'm going to do df, and I'm going to use the is null argument. Okay? And what the is null argument is going to do is, if we look at this, it's going to give me a Boolean data frame. And for those cells in the data frame where there are values, it'll say false. So this is a little counterintuitive. But what this means is basically in the first row in the operation column, we can see that there is no null value. So this is false. Now this isn't particularly helpful. So why don't we take this and instead let's do sum. And what this will do is it's going to sum along the x-axis, so along the column axis here. So if I hit Shift and Enter, what I get back is a series. And keep in mind that in terms of math, true, the Boolean true, always evaluates to 1. And so this is showing me how many trues or how many null values are in each column. So we can see specifically that in surface area total, there's 1,800, and then some of our worst offenders here, floor, 4,600, etc., etc. Now, if I want to be really fancy, I could take this code and I have a series here, and I could actually divide it by the length of df. So I would be kind of normalizing these. So instead of raw counts, I would get a floating point value. And we can see that some columns are not a big deal. For example, latitude and longitude, only 4% of our observations are missing. But like we've said before, you have some of these big offenders like floor, where 70% of our values are null, or expenses, where 73% of our observations have a null value. So what does this all mean? Well, generally speaking,
Okay. What we want to do, we want to write a procedure where we calculate the percentage missed. Okay, and if the percentage is missing, is less than 50, then we want to drop the column. Okay? Right? That's how you do it this. Oh, you happen to think about this one, aren't you? That's interesting. Okay. Hmm. Mhm, 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 mhm.
If your column has more than 50% missing values, then it's probably time to drop it. And what that means for us here is that the floor column and the expenses column, they gotta go. See you later. Sayonara. Goodbye. With that in mind, let's zoom out and go up to our wrangle function. And let's make some adjustments there because it is time to get rid of those null value columns, which aren't really giving our model the information that it needs to be useful. So what I'll do is, let's see here. I will just put in a little comment here. So I'll do drop features with high null counts. And let me zoom in so that it's easier to see. There we go. And this is going to be our regular old drop. So I'll do df drop. And then for columns, I'll set that equal to, let's see here. The two columns that we wanted to drop are floor and expenses. There we go. And I will set this to in place equals true. In place equals true. And I can see that autocomplete has kind of messed up my columns argument there. So I'll remove that. And then I'll hit Shift and Enter to rerun this. And if I zoom out, I can then, actually, why don't I go down to the part of the task where I need to do this. So I'll scroll all the way down to my Explore. Here we go. And what I'll then do is I'll go up to Run and do, let's see here, run all above selected cell. So this will run the whole notebook from the top down to where I have my cell selected. There we go. And what we'll see is that this assert statement has run, and that means that my column is now, that those columns are now dropped. So we had 17 features when we first wrangled this data. Now we have 15. Let's keep on going. Let's see what we can keep and see what we need to throw away.
Hmm.
The next bit of exploration I want to look at is low and high cardinality categorical variables. And there are a couple steps to this, so we're going to break it up across two tasks. For the first task, what I want to do is I want to look at just the categorical features in my data frame and see how many unique values are in each of those. So I'm going to start with df, and if ever you want to subset your data frame based on the data type of the columns, you can use the select dtypes method. And because we're looking at categorical variables, what we want to do is we'll put object here because we know that the data type for each of those columns is object. And if I do .head, we can see here they are. And some of them are going to be familiar because we created them. So here's our neighborhood one. But then we have some other ones like operation, property type, currency, etc. Now I'm going to, let me create a new cell down below here, just so that we can kind of see this head while we work. Let me get my head out of the way. All right. And I'll take this bit of code here. And what I'm interested in are the number of unique values in each of this column. So for example, here in this operation column, we can see that one of the values is sell, but are there other categories here? Like, is there a buy? I don't know. So what I'll do is I'll do select dtypes object, and then I'll use n-unique. N-unique. And that's going to give me a series. Beautiful. And if we look at the numbers here, the values here, we can see some interesting things. So first, if we look at operation and property type, we can see that there's only one unique value, which means that operation and property type, everything here is sell, 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 sell.
You know what? I may make this the last part of this, which means it'll also be the last. We have to wait till Sunday night to wrap up this section here.
An apartment, 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 apartment. Now, these are examples of low cardinality categorical features. Some people even call them constants. And these are the sort of features that you want to remove from your feature matrix because they don't actually provide any information to your model. Remember that your model is trying to distinguish between apartments so that it can predict the price, which is more expensive, which is more economical. And if this feature is the same for every single apartment, there's no information here for your model to make any sort of distinction. So these are the examples of low cardinality categorical features that you'll want to drop. I think we can also add to that list currency. If we look here at currency, we can see that this is USD, and I suspect that the other value here is like you have USD and then also local currency. So that's low cardinality categorical features. What about high cardinality? Well, if we look here at property URL right here, and then right here in the data frame, we can see that there are 6,582 unique values in this column. That is to say, every single row has its own unique URL, which makes sense because every property that appears in this data set is going to have its own unique URL where you click on it and you see the photos and you decide whether you want to buy it or not. Now, why are these features not good for a linear model? Well, one, if I had to one-hot encode all of these URLs, suddenly I would go from a data frame that had 15 features to a data frame that had over 6,500 features. And we talked about the cursive dimensionality. This would be like cursive dimensionality on steroids. So if you're going to do one-hot encoding with a linear model, these high cardinality features might harm model performance. Not to mention, in this case, I don't think the math would work because your data frame would be wider than it is long. So you couldn't do ordinary least squares regression. Another way to think about it is your model is looking for trends. For instance, certain neighborhoods happen to be associated with higher property prices than other neighborhoods. But if you have a feature where each observation is a unique value, there's no trend that you can identify. So, in the same way that a low cardinality feature doesn't give useful information to a model, high cardinality features also don't give useful information to a model. Except that with low cardinality, it's because you're basically giving no information, and with high cardinality, it's basically information overload. So what does this mean for our model? Well, what it means is that of these categorical features, it looks like these four, operation, property type, currency, and property URL, we need to drop them. We're not going to be able to use them. All right, we've identified our low and high cardinality categorical variables that either give no information or way too much information to our model, so we can't use them. And so what we need to now do is take these four columns and drop them in our wrangle function. So I'm going to zoom out here. Let me remove my drawings, and then let me zoom up, or scroll up rather. And we want to remove all of these guys from our data frame. There we go. I'll zoom in, and let's get to coding. So let's see here. I'll just say that I want to drop low and high cardinality categorical variables. And then the code is going to be df drop, except instead of dropping the columns that we did up above here, we're going to drop some more columns. So these are going to be, let's see, operation, what is it? Operation, property type. We had currency, and then lastly we had property URL, so their website URL. And then the last thing we want to do is we're going to add in place equals true. And then I'll zoom out and hit Shift and Enter. Beautiful. And then I'm going to scroll all the way back down to where we were before. There we go. And I'll again do run, and I'll go run all above selected cell. And we can see that this cell has run, and we passed the assert statements. And so we're good to go.
Okay. And we're going to call this part of it to a close. Okay, so here's the question. Can we install apt as part of this right here? But this is the same point. Why am I installing another package manager? Okay. If the point is to keep it light and fast, I shouldn't need a second or third package manager. I mean, I shouldn't have to try to figure out how to install Git using Puppy Manager. Okay. That's my continuing complaint. Anyway, let's go over here. Let's That didn't work either, did it? Okay. I've tortured myself enough about this. Restart graphical server, restart window manager. Okay. I'm going to go ahead and bring this session to a close. Keep your eyes open and maybe doing a stream on Sunday night. As always, if you click on that bell icon, you'll be notified whenever I go live. If not Sunday night, certainly Monday night. We get a Monday through Thursday session. Thanks so much for stopping by. You guys, hope to see you very soon on the next stream. All right.